Okay, so in this video we will be looking at the user interface of SOLIDWORKS CAM, and so let's take a look at what are the different commands those are available here for on the SolidWorks CAM. So obviously first thing you're gonna have to do is add in the SolidWorks CAM in your SolidWorks, and once you add it in and you open the the sample part file from the canvas. The name of the part file is lesson 1 with toolpath. So take a look at this screen, and obviously this top line here is the file, edit, view, insert, typical menu bar, and the underneath that is this pull down menu, which is the command manager and the command buttons. Obviously this area is the feature manager design tree, and then you got the status bar with the short message also that appears here. Then in the graphics region you have this graphics area, then you have the reference triad, then the status bar here. On the lower right corner you have the unit system. Then this is the heads up view toolbar. Let's see what else we have. Then the resource center, and some of the the standard features which are by default available here on the command manager. Alright, so I have the SolidWorks CAM tab open, and that's how I'm able to see all these different commands there. Okay, so now I'm gonna use this part file in the SolidWorks. So I have opened it here, and all these extract machinable features, the generate operation plan, generate toolpath, simulate toolpath has all been done here, as you can see on the feature manager design tree. You can take a look at what the milling machine is used, then the stock manager, then the coordinate system, then the part setup for the milling machine. So first you're going to do the rough milling, then the contour milling, and then the center drill, and then the final drill to create all those drilling holes. And so this is all what the operations or the tool path that we have generated it. And quickly I'm going to show you how to simulate it. So if you click on the simulate the tool path, you can adjust. Basically this green colored overlaps the the actual part, and that is basically the stock, initial stock that to begin with. And you can like I said, you can adjust the speed here, and if you play this, then it will tell you how the toolpath is created. So first rough tooling, and then different tooling that is been used for the milling machine. And so that way you can see the simulated tool path. Then that was the center drill, and then the final drill to create all those holes there. Alright, so that's basically what the CAM software can give you, in terms of the virtual machining. Okay, as how the tools can be simulated on your part that needs to be fabricated. So let's take a look at some of the major command buttons in the SolidWorks CAM. So the first one is the define machine, which basically allows you to define the machine tool that the part will be machined on. For example, a 2.5 or a 3-axis mill, and so on. So if I click on that define machine, I can see some options here available. Mill inch, which is the standard, then you got the 4-axis, 5-axis, and also for the turning machine also the option is there. Okay, so you're gonna select that which was already selected. That's basically how you saw this machine mill inch was indicated there. Okay, then you got all these other options there, the tool creep, and the the post processor, and the posting, how do you set up if there is any rotary axis available, or if there is any tilt axis and all that, some of the advanced features in that. So that's the first one, which is the define machine. You're going to basically define what kind of machine tool that you want your part to be machined on. Okay. The next one is the coordinate system, and that's also very important piece of the puzzle here in any machining process, because that is what it decides how the G codes will be created, and all the tool paths are based on the coordinates on the plane that it is moving on. So the coordinate system is very important, and so the coordinate system allows you to define the coordinate system and assign that as a fixed coordinate system for the active machine. Then below that you have the stock manager. The stock manager allows you to define the mill stock from a bounding box, and there are various ways to create the stock, and you can create using the sketch or from the STL file, or from some of the parameters that can adjust for different X, Y, and Z axis direction. So there are different ways of creating the stock, and so the stock manager is also something that we're going to play with. And also, some of these videos regarding how to create different types of stocks, you can look at it from the Solid Professor videos also. Then the next one is the setup. So in the setup, it will allow you to create the mill part setups that defines the tool orientation, or for example, feed direction, or the G code program 0 where it starts, as a part of the setup, and also the X direction of the tool motion. So all that comes under the mill part setup. Then we have the extract machinable features. We talked about the automatic feature recognition, AFR, in the earlier slides in the previous video. And so this option basically initiates the AFR to automatically extract the solid features and that correspond to the machinable features. And these are defined in the technology database, TechDB. The types of machinable features recognized for milling and the turning are different, and so the SolidWorks CAM determines the types of features to recognize based on the NC machine selected. All right. Then we have the generate the operation plan. So that basically creates machining operations for all machinable features, and based on the rules which are defined in the TechDB. All right. Then we got the generate toolpath, and so obviously the generates it generates the operation plans automatically for the selected machinable features. The operation plans and the associated parameters are generated based on the rules which are again defined in the TechDB. The operation contains an information on how the machinable features will be machined. Okay, and the operations generated in this step are listed in the feature manager window under under this CAM manager tree here. Okay, so those were the different holes, as you can see there. Anyway, so the next one is the simulate toolpaths, and this one provides the one that we just looked at, a visual verification of the machining process for this for the part by simulating the tool motion and the material removal process, the one that we just looked at in that video. This one. Okay. Then we also have the step through toolpath, which allows you to view the toolpath movements, either one movement at a time or a specified number of movements, or all the movements. So you can break them down into different steps. Then the save CL file, it allows you to save the current operation and the associated parameters in the technology database as the CL data for the future use. The CL stands for cutter location. Okay. Then the post process basically translates the toolpath and operation information into the G code for a specific machine tool controller. Okay, so that's basically comes under the post processing. All right, and so and then you have these 2.5 meg access mill operations, and then the whole machining operations, 3-axis mill operations, and so on. So and also like I said, you also have this in the standard as well as in the professional SolidWorks CAM, the tolerance based machining, which is also very important when you're trying to machine the parts with the high precision, or with some constraints on the tolerances. Alright, so that's basically the user interface for the SolidWorks CAM, and in the next video we will take a look at the NC part programming.